so this is the user interface of Ansys Workbench. So here you can see all the tools which we can use in for analyzing the component in different domains. Like we have fluid flow CFX and Fluent, which is used for CFD analysis. After that we have modal analysis, static rigid dynamics, static steady state thermal, transient thermal for different analysis. Also have the topology optimization, which is very useful tools nowadays to optimize the material. So we will start with modal analysis first, because it is the simplest and easiest method to find out the component under vibration. So when we double click on this model, so it will open a window which have different steps over here. So you can see here we have a green tick. It shows that the engineering data is already completed. So by default it has a material of structure steel in it. If you not assign any material to the component, it automatically take as a structure steel. So if you want to change the material, you need to double click here and you can assign the material accordingly by adding over here. You can see here it has a click here to add material. So you can add any material which you want. You can find out the properties or mechanical properties from the internet and you can add different material. So right now we are closing it because we go for the analysis first. After that we will learn how to add materials. We are taking structural steel as a reference material. Now we are going for the geometry. So here we have different options. So we can create the geometry as well as we can import the geometry. So here we have two modules to design the geometry. After that we have another module that is called import geometry. So if you want to make the geometry in the different software, suppose like CATIA, SolidWorks or something else, so you can make your geometry and import into the Ansys Workbench easily. So here we are going for the designing of geometry. So when we click here, okay, so now the user interface is open. So you can see here we have three face or three plane to create the geometry. So I clicking on this XY plane. So this is my XY plane. Then I click on sketch and make a rectangle over here like this. I click here to make a rectangle and again I click here to change the unit, because now the dimension are is in meters, so we click on millimeters. So after that I click on dimension and then click here and then click here. So these are the dimension which we are giving here. So H is represent over here. You can see the details of H. It is showing this and V is showing is here. So this is 150 for example, and this V is of 20. So now our sketches look like this. You can see here this is our sketch. It is represented with blue lines. Okay, so after that I click on extrude. So once your sketch is completed, you click on extrude. It will give the third dimension to the sketch. You can see now it is converted into the box, and this represents the extrude length. You can see the dimension of extrude length. It is 30 millimeters. So you can change it to 600, and after that you click on generate. When you click on generate, it will generate the geometry like this. So you can see now it is the extruded geometry. It becomes a plate. Okay, so you can make this type of plate or this type of design in Ansys user interface, as well as you can make it in different software and import into the Ansys Workbench. Now our geometry is completed. So I click here to close the window. Now you can see here that the geometry also has a green tick. That means the geometry part is completed. So what we need to do, we just double click on model to open the model user interface. Okay, so now this geometry is completed. So I open the user interface of model analysis. You can see this shows the information tree. Whatever the information which you required, it already shown here. Okay, so suppose this is our geometry. If you want to know the details or dimension of this geometry, you need to click on this plus icon just near the geometry portion. You just click over here. It shows solid. And when you click on solid, it will convert into the green. That means you have only one part here. If you import here or design here as an assembly file, so all the component which is included in the assembly file, it shown over here. by name solid 1, solid 2, solid 3 and solid 4. You can assign the material according to them. Suppose for example if we import here as a screw jack, so that means there are so many components over here. That means first one is the body, then we have cup, then we have spindle, then we have Tommy bar. So we need to assign different material to them. So you just click over here to that part, and you can assign the material by going in the detail window, which is just below this information tree. So you can here see here that materials, it is having an assignment, that means structural steel. So right now we have only one material in this engineering data library because we didn't assign any material to them. If you want to go for the analysis with different materials, so you can add the material in engineering data over here. You can add material here. So if you add the material over here, then when you click on here, so it will show all the name of the materials. Okay, so this is the information about the geometry. Then we have mesh. Before going for the analysis, we need to go for the mesh, but before this we are applying the loading condition or the constraint to make the thing. Suppose we are going for the vibration analysis of this plate, so we need to give boundary condition to this plate. Suppose this is a cantilever plate. So if it is a cantilever, so we need to fix this plate from one end, either from this side or this side. So suppose we want to fix this from this side, so we need to click on this face, okay, to fix this thing. Before going for this, we need to just click on here on model, then go for insert, then we have a fix support. When you just click on the fix support, it will add it here, but it is asking for the geometry or the portion which you want to fix. So I am fixing from this side. So when I just click on here and click on apply, so it will fix this portion. You can see now it is converted into blue, and blue represent that fix support, and here you can see only one face is selected. So this is the procedure for applying the boundary condition. So I'm fixing it from the end to make it cantilever. So this side is fixed, that means it's make a cantilever shaft. Okay, suppose if you want to fix this not by the face, if you want to fix by the edge, so you need to change the selection. So here you can see that it is a vertex. Suppose if you want to fix this plate with a single point, so you need to select this, and after that you need to fix this with the edge. So I am giving you a demo of edge. Suppose I am clicking on here, so next time when you just click here, so it will select the edge only, and then when you just click on apply, so it will fix this edge only. But in this analysis we are making it cantilever or fixing this complete face. So we need to click on the face and then select here and then click on apply. So it will select the face of the plate. Okay, so now it is a cantilever. So now we going for the meshing. When we right click on the mesh and click on generate, so this is the simplest method to generate a mesh, but it is not working in different component. If you have a circular object or different complicated, suppose you have a crankshaft, it is very complicated geometry, so it will not create the mesh with perfect dimension, so you need to modify it. You can see here that this is the complete plate is divided into different parts, so it will solve the component one by one. If we have this quad mesh, you can see this is the quad mesh. Now you can see here all the elements are having 4 corners, so that is the quad mesh. So this is a very good mesh in terms of analysis, but the element size is very big. So if you want your result precise, so you need to decrease the element size. So how you can decrease the element size? You just right click on the mesh and click on insert. So these are the methods through which you can change or improve your meshing. So right now I'm going for the sizing. I'm here in this analysis, I'm using the sizing tool. So when you just click on the sizing, it will asking for these 2 things. First one is the geometry, and then this one is the element size. So you need to feed the element size over here, but first you need to select the geometry, on which geometry you want to apply the sizing command. So I want to apply the sizing command to the complete body. So you have here the selection procedure. So you have the body selection option, as well as you also have a box selection procedure. So this is the 2 method through which you can select this thing. So I am selecting here the box selection. So whatever the things which come under this box, it will select completely, and I just click on geometry and then apply. So this geometry is selected for sizing, body sizing tool. Okay, so what we need to do, we need to just add the element size. So I am giving here 2 millimeter, for example. So it is showing meter, 2 meter, but we have to feed this in millimeter. So we need to change the unit, that means in mm. So here I am giving 2 millimeter. So again, when you give the size, you just right click here and click on generate mesh. So now when you click on the generate mesh, by reducing the number of elements or by reducing the element size, it will take time to generate the mesh, because now the elements become very small. So it will take time to generate the mesh. Now you can see the mesh is completed and you can see the refinement. Okay, whatever the size we have in the previous meshing, now it is completely refined. You can see that this is the mesh design. Now we have so many elements of very small size. Okay, so after that, when you complete the boundary condition, when you completed the meshing, you can go for the analysis. So in this analysis or in this model analysis, we just applying the boundary condition, that is material property as well as the fixed support. So after that, you just click on solution and just click on solve. So it is solving the component by taking the two boundary conditions, that is material properties and fixed support. Actually it takes times because we improve the mesh with a very small size. Okay, now you can see that the solution is completed. We have all the result showing over here in the table as well in this chart. So if you want to see the deformation in different mode shape, so we have calculated the model analysis for 6 mode shape, because when you go for the analysis setting, you will find out that we have 6 modes. So what the meanings of these modes? So you can increase the number of modes here, you can increase or decrease the number of modes. So for this analysis we selected 6 modes. So what these mode is actually about? So once you go for the model analysis, you need to find out the vibration, in which condition this material is going to fail. Maybe in tensile, maybe in compressive, maybe in twisting, maybe in bending. So we have to find out the modes, in which mode it's going to fail. Okay, so the software generate the loading condition accordingly and give you the deformation or the failure condition, in which mode on what frequency it is going to fail. Okay, so we have selected 6 modes. So when you want to see the result of these 6 modes, you need to click right click here on this graph and click on select all these mode is selected. Then again right click here and click on create mode shape results. So once you click here, all the results is showing over here. You can see here all the result is showing. So you can see these result one by one. When you import the result of deformation, once you need to right click here and click on evaluate the results. When you click here, so all the result is shown. Now it has a green tick, that means the result is completed. When you click on the deformation, so it shows the results in first mode shape. So you can see the result over here with respect to the color contour graph. So you can change it to the smoother like this. You can see here or you can see in the wireframe mode. So this wireframe shows the actual component and this color shows the deformed component. So once you play the animation, you can see it is applying the loading condition in this direction, like this, in this direction. It is like in this direction. Okay, so it shows the bending. In first mode it is like this. Now we go for the second mode. So when we play animation, you can see now it is a bending like this. Okay, so if you go for the third mode, you can see now it is bending in this direction, in the horizontal plane direction. Okay, now if you go for the next mode, that is fourth mode, you can see it is twisting like this. So it is fixed from this side and it is twisting like this. So the front portion is twisting. So it gives the deformation of failure in different mode. So in first mode, you can see it has a failure frequency of 45 45, it has a failure frequency of 45.895 hertz, and you can see that maximum deformation it take place over here. You can see this is shows in the red color, so maximum deformation is 6872, and these are the values of color contour graph, so you can find out. So here we have minimum deformation because this is the fixed portion or the cantilever portion. Okay, so these are the result of the frequencies. Okay, so this is a cantilever type of shaft or cantilever type of plate. So first is showing that 45. First, in first mode it has a frequency of 45, and in second mode it is increasing, third mode it is increasing, fourth mode it is increasing, and it is increasing. It is start increasing and after first mode. So this is the minimum frequency on which it is start going deform. So that means it is the resonance frequency of the component on which it is start bending, or it is start deforming. Okay, so you can see the first mode shows the resonance frequency of this component. Okay, now we are going to change the analysis. Suppose this shaft is fixed, or this plate is fixed from the both the ends. Okay, so when so again we are going for the fixed support. Here you can see we go for the fixed support. So if you go for fixed support, here you can see only one face is there. Okay, only one face is there, which is this, which we select which we select earlier. Now again I'm clicking on this face, and I'm clicking on this face and press the control button, and again I'm clicking on this face. That means both the face is selected, and then I click on apply. Now it's showing two faces. That means first one is this and second one is this. So now both the faces is fixed, and that means now it is not a cantilever shaft. It is fixed from both the ends. Again, what we are going to do, again we are right clicking on solution and then click on solve. That means now it is solving this plate with changing the boundaries. Now the plate is fixed from both the end, and it is solving the results. Okay, now you can see here in previous analysis when the shaft is cantilever, so it has a failure frequency of 45 in first mode. Now we click on the first mode, or you can see the frequency is increasing to 292.66 hertz. When the this plate is fixed from both the end, so it need a frequency of 292.66 hertz to fail. And what is the condition of failure? When we click on the animation, you can see it is bending from the mid portion. Like we have the condition of bridges, when the bridges is fixed from the both the end, so maximum chances of failure is at the midpoint of the bridge. So this is the procedure to find out the failure reason from where the material is going to fail under vibration conditions. So you can see the red portion shows the maximum deformation. That means it is going to fail from this portion, and when the failure frequency is 292.66 hertz. If we change the material of this plate, then definitely it will change the failure frequency. It can be increased, it can be decreased according to the material properties. Okay, so this is a quick demo of our model analysis. Now I am closing this module because it's already done. So I think you have understood what is the meaning of model analysis. After that we are going for the next module, that is static structural. In model analysis we need to find out the deformation with respect to the failure frequency, but in static structural we find out the deformation, stress and strain in a component. When we apply the loading condition to them, it will deform and it will give us the results. Okay, so I'm clicking on the static structural over here. So this is the module in which we are going to find out, or we are going to test our material under loading condition. So we need to draw again we need to draw a plate just like we draw in the previous. Suppose you want to analyze that plate which you are which you have in the previous analysis. So you can import that drawing into this static structural module by I'm just clicking on this geometry, you can see here, and after that I am dragging this geometry into this over here. And when I leave this mouse button, left button, so it will import the geometry from here. Yeah, now you can see it also has a green tick. Whatever the geometry we made in model analysis, now it is imported to the static structural analysis. Same geometry, no need to draw a different geometry if you want to go for the analysis of for the same component. Okay, so now we directly move to the model. When you double click on the model, it will open the module or user interface of static structure. Okay, now you can see the user interface of the static structure. So here you can see all the information of the component. So when you just click on here, so you can see the solid, like just in the previous analysis we have this component. So you can change the material property from here similarly to the model analysis, and you can go for the meshing also just like in the previous. And now the name is changed. In previous we have model, but now we have static structure. And when you just right click on static structure and go for the insert, you have numbers of boundary condition which you can apply in static structure. In the previous analysis we have limited numbers of boundary condition like fixed support or something else. But in here you can apply different things like acceleration, pressure, force, remote force, linear pressure, thermal, displacement, and fixed support. You have numbers of loading condition or boundary condition. Okay, so again I'm testing this component, just making this shaft as just making this plate as a cantilever. So you need to rotate this and you need to apply a fixed support over here. So I'm right click here on static structure and then click on fixed support. So it is asking for the geometry. So I just click here to select the face and click on apply. So it's going to fix the plate. Now it is cantilever type. Okay. So next thing what we are going to do, we are going to apply the loading condition. Okay, so loading condition you can apply as per your requirement of the questions which you have or the problem which you have. So you can apply load on this complete face also. You can apply a load on this edge also. Suppose you want to apply a force on this edge. Okay, so this from this side it is fixed, and from this side you want to apply a load in the downward direction. Okay. So I'm selecting here the edge. So I click on this edge and click here. Okay. So right click on static structure, go for insert and then go for force. So now the side is selected. You can see now it has a red portion. This edge is converted into red, and red shows the force, but it has 0 Newton because we didn't give the magnitude to this thing. Okay. So now I'm giving the magnitude of 100 Newton, for example. So when we give this 100 Newton, you can see the arrow is in this direction, but you want to make the force in downward direction. Okay, but it's showing the wrong direction. So what you need to do, you just click here. Here we have by vector. Okay, so you need to change it to the component. So when you change to the component, it has X component, Y component, and Z component, and it is represented over here. You can see this shows the Y, and this shows X, and this shows X. So we need to apply the force in downward direction. That means the direction of Y in the negative. Okay. So what you're going to do is just click on this on Y component and just hit 100 and then hit enter. So it shows that the force is applied in the Y direction, but in upward direction you can see. Okay, but the force is in upward direction. The plate is a cantilever type. It is fixed from this portion, and now the force is applied in the upward direction, but you want this force in the negative direction. So what you're going to do, whatever the amount you feed over here, you just put a minus sign before the value. Okay, and just hit enter. It will change the direction. Here you can see now the direction is in downward direction. Okay, so 100 Newton force is applied in the downward direction. So once you click on the static, so you can see all the loading condition in once. You have a fixed support and you have a force of 100 Newton. It is represented by B with the red color. You can see here you apply a force, and it is represented by A, the fixed support. A is showing over here. You can rotate and you can see the blue portion shows the fixed support. Okay, now you already applied the loading condition as well as the boundary condition. So now you're going to do for meshing. So right click on mesh, click on generate mesh. It will generate the mesh in a simple manner. Okay, so you can increase the mesh size by right click on insert and then go for sizing, then select again the complete body. You select the complete body, then apply element size. For example, I'm putting 10, and then again I'm right click here and then generate mesh. It will decrease the size of the element. You can see here now the size is changed. After applying these boundary condition, you need to right click on solution and click on insert. Whatever the things you select from here, this will represent the results, okay, what you want in the output. So suppose we want a deformation, you can find out the directional deformation as well as the total deformation. Suppose for example I want to find out the total deformation. So first I click total deformation, then again right click, insert, then strain. So equivalent strain I want to find out, and then stress and equivalent stress. So these are the three results which I want as an output. Okay, so again I just right click on solution and click on solve. So now it is solving the complete geometry under the boundary condition. Okay, now it is completed. You can see now we have a green tick on all these results. So first we just click on total deformation. So this is the result of total deformation. You can change it to the wireframe. Okay, so this wireframe shows the actual component before the loading. Okay, once you apply the load at the edge of this end, so it will deform in the downward direction. You can see here like this. Okay, you can see like this. When you click on the static structure, you can see that we apply a load in the downward direction. That means it will bend the plate in the downward direction. So result is showing in the same way. You can see that it is moving in the downward direction. Okay, so these are the result of deformation, because the maximum deformation take place at the end of the tip. It is represented with red color. Okay, so next thing is we go for the strain. So these are the result of strain, you can see, and when you click on the stress, you can see the result of stresses. The maximum stresses take place over here, from where when it is a cantilever. Okay, we already know that if I apply a load in this direction, so it will try to bend or try to break from this side. Okay, so these are the result of total deformation, and you can change the boundary condition as per your requirement. Okay, suppose if I want to change the loading condition, now it is not the load is not applying in the downward direction. So again I go for the force. This force is applying in the downward direction. Again I am clicking on the face and selecting this face. Okay, and then click on apply. Now the face is selected, and again it is moving in the downward direction, but I want this place under compressive loading. Okay, so I am applying a force in the compressive manner. So what we going to do, we need to change the axis. Now it is y axis, it is applying in the y direction, but now I want in z direction. Okay, the negative z direction. So from here I am putting 0. Okay, and from z component I am putting -100 and then enter. Now you can see the force is acting in the negative direction of z. That means it is a compressive. When you click on static structure, you can see we have fixed support over here, and we have a force which is moving this face in a compressive manner, or in this direction, or minus z direction. Okay, again I'm right clicking on solution and then click on solve. So now solving this plate when it is subjected to a compressive load of 100 Newton. So you can see the result. Okay, so these are the results. The portion which is represented by the wireframe, it is the original component, and now you play the animation. It will shows that when you apply a load of 100 Newton, it will deform in the compressive manner. Okay, and after the load, you can see these are the maximum deformation which take place when you apply a load of 100 Newton in compressive direction. Okay, so these are the result of strain. Maximum strain as take place over this corner and this corner. You can see the results, and you can see the stresses, and the maximum stresses take place at this region. Okay, so this is a quick demo of static structure. So how you go for the how you apply the boundary condition and how you solve the component with different loading. So if you want to change the loading, you can change, or you can add different loading also. Suppose I apply here a force, and again I'm right clicking on here, and again you can apply a pressure over here, a twisting load. whatever the loading condition you can apply. You can apply number of loading condition to a component. Okay, you can apply pressure on this surface also. So this is a quick demo how to analyze a component in vibration condition as well as in the static structural condition. In modal analysis, you find out the resonance frequency or the failure frequency, but in the static structure you find out the deformation, stress and strain under the applied loading condition. Okay, so now I'm closing it because it is I think you have understood how to analyze in a static structure. Now I'm closing it, and now I'm moving to the different module, that is static thermal. Okay, so again I'm double clicking on static thermal. So I'm going to test a plate in which it is subjected to a load of or thermal loading condition. So we need to draw a different geometry. So I'm just right clicking over here and then go for design. Okay, so the user interface is open now for designing. So I just clicking on this plane and click on sketch. Okay, now I'm clicking on the circle and I am going to draw a circle over here. Just go for the unit and click on millimeter because we are designing this circle in millimeter. So just click on dimension and click over here. Okay, so it shows D1, that means it represent this. So the diameter of this circle is, for example, 20. You just hit enter, and when you zoom this thing, so you will find out the diameter. Okay, so this is the diameter of 20 mm, that means 2 centimeter. Now just I click on extrude to give the third dimension. Okay, so I'm extruding this to the length of 80 or 100. Okay, so this is the length for this, so this is 100. Now I am clicking on generate to make this component. Okay, now this is the rod which we have created here. Now I'm just closing this. So you can see the geometry is completed. Now I am double clicking on model to open the steady state thermal module. So this is the user interface for steady state thermal. Okay, you can see now the name is changed to steady state thermal. Okay, as per the selection of module. Again, similarly, you can change the material property by clicking over here, and you can go for mesh also. But before going for the mesh, we are applying the loading condition. Okay, so in this we just right clicking on here and go for insert. So these are the numbers of tools which you can apply, or number or the boundary condition which you can apply here. Suppose I am applying the temperature, so I'm just clicking on temperature and clicking on this base. Okay, this is the base which we have selected, so I click on apply. So this shows the temperature, and the temperature applied temperature is 22 degrees C, and this is the room temperature. So we need to increase this temperature by clicking on this module, magnitude. So I am putting here of 900 degree. So 900 degrees C I applied at the base of this rod. So after that, again I'm right clicking over here and going for the convection, because the rod which we have over here, it will convect the heat. So I select here and again press on control button, and then again click here. So this is the portion which is going to convect the heat when we apply the heat from here. So this portion will convect the heat. So we need to give the film coefficient for convection. So I don't have the value of that convection, so I'm putting here 0.01 for convection. Okay, so you can change the value of convection, because right now I'm just giving a demo, so I'm just giving the random value for that. So just click on geometry and just click on apply. So whatever the geometry you have selected, it is applied and it is converted into a yellow portion, and it shows that it has a convection value. Okay, so you just click on steady state thermal to know whatever the boundary condition you have applied. You have a temperature and you have a convection. Okay, so after that you just right click on solution and then click on thermal and then click on temperature. So suppose you want to know the temperature of this, and again click on solution and then click on thermal and click on heat flux. So these are the two things which you want to calculate for this, and right click on mesh and click on generate mesh. So you can see now the mesh is completed. You can see the mesh element is of big in size, you can see here. So what you're going to do, you can increase the mesh. Just right click over here and you can increase the meshing. Okay, I'm using again sizing and just click on geometry. So this is the body selection. Again, element size is of 2. For example, I'm putting here 3 because the component is of very small. So again, right click on mesh, then generate mesh. So it will take time, but it will improve the meshing. Okay, so you can see the number of elements now increasing, and it's become smaller in size. So all the boundary condition is applied. Now just right click on solution and click on solve to find out the results. Okay, so now this solution is completed. Okay, so you just click on temperature. You can see the results of temperature. Just go for the smooth. You can see here. Okay, so you can see that the complete rod is of showing the minimum temperature, that is 22. That is the room temperature. What it's mean? Because the variation of the temperature is under this region only. Why? Because whatever the temperature you apply over here, it is goes up to this extent. In 1 second, it is goes up to this extent. If I analyze this rod for 10 seconds, so maybe it will reach to the mid, or maybe it will reach to the more than the midpoint. So this is the response. The temperature is goes up to this limit, and after that it is showing that it is of minimum temperature condition. Okay, so once you click on the total heat flux, this also shows the reading for total heat flux. Okay, so this is a quick introduction how you can calculate the thermal analysis also. So that's it for today. I hope you understand how to analyze a component under vibration condition, under static loading condition, as well as under thermal conditions. So I hope you understand all the 3 module of the Ansys. So thank you for watching. Thank you for watching. Please subscribe the channel for more related videos.